What is up, self-made Homestead family? In our last video, we built the motor mount and the battery tray for these awesome items here. In today's video, part 2 of the self-made, self-powered series, I'm going to teach you how to wire everything up. So here's the get down. I'm going to bench wire everything so it's nice, flat, level, and clean. Then we're going to install everything in place. I'm going to end up tucking that underneath my staircase here in the basement so that if I need to, I can run power off of this awesome inverter. But before we get into any of the wiring stuff, I want to make sure you understand the fundamentals, or as I like to call them, the fundies. So to get these batteries to work the way I want them to, we're going to connect them in series and in parallel. So we're taking 4 batteries, separating them into 2 pairs, using the positive and negative terminal, linking them together, and then linking those 2 pairs together, thusly. So that's the charge controller at the top. Positive and negative terminal, positive and negative terminal, negative on one side connected all the way up to the charge controller, positive on one side all the way up to the charge controller. For cleanliness and ease of service, I'm going to use raw wire here because that's what it's formatted for, to a quick connect here, so that I have everything dialed in. I can remove the batteries from series to service or charge them individually, and that is huge. Same here. This is where the load goes in, or out rather, from the charge controller. So we're going to take it out of there, raw wire, into these ring terminals to the back of this inverter. Also, for the generator motor, we're going to go raw wire out and then splice them together with these couplers, because I want to make sure that I can take it apart if I need to service everything. That's key. That's step 1. Make sure that everything is serviceable in the future, because you want to make sure that maintenance is the last thing you're worried about in an emergency situation. Okay, moving on. Let's walk through the components. This is a charge controller. I remember in the last video I said that I would put everything in a description, but I want to make sure that I have everything. So you have everything you need to build this thing in one video. That's what we're doing. So in this video's description, make sure you take note of the links that I put in there for all of this stuff. I'm not getting paid by any of these guys. I want you guys to have this free information, okay? It's important. Power your family. Take your power back. That to me is far more important than affiliate marketing at this juncture. So here's what we're gonna do. This is the solar charge controller. Always give yourself some wiggle room, okay? Rated voltage, 24 volt auto detect. Rated current, 30 amp. Max voltage, 50 volts. Now, check this out at the back. 390 watts in 12 volt, 780 watts in 24 volt. We're running 24 volt. This gives you headroom. You need that, so that if you accidentally pedal too hard, you're cranking it because you're vibing out to the music you're listening to or whatever, that will give you a little bit of headroom. Check out step number 2. Make sure you got headroom. First step, make sure you got serviceability. Second step, make sure you got headroom. Awesome, my pellet stove is feeding in the background. It's raining like crazy. We're expecting rolling blackouts, so I'm trying to get this done because we need it. All right, so 780 watts, 24 volt, that's what we're running. It's a PWM charge controller. You got MPPT and PWM. Research the difference, Googleize that thing, and you'll educate yourself. Moving on. From the load side, coming out of the charge controller, we're running into this Syntec, it's a Harbor Freight find, vintage Harbor Freight find, inverter. Here's what it's rated for. Remembering the rule, headroom, right? 750 watt continuous, 1500 watt peak, 12 volt nominal. So I've run this thing off a 12 volt battery before. It comes with posts, terminals with the ring terminal on one end and alligator clips on the other to connect the posts. Used to use it in a marine battery situation. So we're gonna try this one out. I have several others here on site that I can show you as we get into this thing, but I wanted to get this out of the way. So power inverter, 750 watt continuous, 1500 watt peak. That's where all the power is going to go. I'm doing that for ease of service. Disconnect here, right? Positive, negative terminals. On the front, you have 2 outlets, right? and you have a USB port. That's going to become crucial here shortly. So, moving past the table, or further down the table, this is the die-cast pulley that I used to convert this chain drive into a belt drive that accepts A belts, okay? That's marine rated cable, 16 AWG, waterproof, IP65 rated for marine applications. We're in my basement, want to make sure that if anything gets wet, it's okay. Because of that, we're using the right terminals for the job. Disconnect females, disconnect males, rated 16 to 14 gauge, okay? 250 tab. I'm also going a little overboard, using some liquid E-tape at all my connections to make dang sure that they're waterproof for reasons I mentioned before. All right, so that's the system overview. Now, for fun, I'm gonna show you what we're gonna wire into it. This is an outdoor rated photocell power supply. You can have it on, off, or dusk and dawn, which is what we're gonna do to make the photocell work. So if you put 2 and 2 together, that means that when the lights go off in my basement due to rolling blackouts, this bad boy will kick on. I'm gonna run a surge strip into that, and I'm only going to power, for now anyway, this pump from my bait shop, which by the way, we're open for business, and a pair of shop lights for down here, service lights. That's off of one side of this thing. That'll leave me one other 110 that I'll be able to use. Technically it's 115 if you remember what it says on this, which is weird. 115 volt, 60 hertz output, okay? Anyway, so I'm gonna have one free side of that. Well, we use that for service and chargers or whatever we need to, but it's only gonna kick on and create draw when the lights go out, which is when we need it. For fun, I'm also gonna use one of these on-off switches for the lights, so I have a little bit more headroom on the lights. So it'll go photocell, it goes dark, photocell kicks on, the air pump will kick on, my fishies won't die, and I'll have light in the basement, okay? So that's how we get an off-grid bait shop. All right, so all the way back to the top, we gotta wire this bad boy up. Remembering that we're going connected in series and parallel, giving us a 24 volt, 36 amp hour battery bank. Let's build it. Okay, some of the tools you're gonna need. That is an awesome set of jeweler screwdrivers for electronics and fine detail work. Got some wire crimpers, and you guys remember my amp meter from the last video. I've also got everything I need to assemble the motor onto the bracket. So we're gonna go ahead and do that now. I used 5/16 bolts, which means I got 1/2 inch hardware. So I'm gonna bolt the motor on, and then we're gonna go from there. Okay, we've installed the motor. Next, install the battery bank. Okay, so the motor's installed, and I've lined up the batteries. Here's what's gonna end up happening. I'm gonna run these to the charge controller, but to make it super clean and so that I can maintain it easier, I remember telling you in the last video that I was gonna come up here with a 45 piece of metal so that I can read it from up here. I'm not gonna do that. I wanna do it super simple because when I'm working out, it's usually super early in the morning and I don't wanna have to think about anything. So what I'm gonna end up doing is mounting a piece of wood that's non-conductive, using wood to metal screws through the handlebars up here. So I still have handlebar grip on the side, but I have a piece of wood behind here that I'll show you here in a second that I'll end up running the charge controller to, which will also allow me to run all the power cables all on lines nice and neat to this. If you know me, you know I used to tech and stage manage stuff, so I gotta have nice, neat, tidy cable runs on everything I touch. Otherwise my OCD goes crazy. Anyway, so here's the batteries. Wise valve regulated SLA sealed lead acid rechargeable AGM batteries, TL 1209s, 12 volt, 9 amp hour, 20 hour rated, okay? So there's that. Just wanted to show you those. Okay, remembering that we're about to connect them in parallel and in series. That's where those are, okay? And then this, again, is the generator motor that I'm using. I'll put all the links in the description, but I want to take time to show you all of these labels, so if you want to pause the video, you can and make a shopping list. All right, so let me get these terminals whipped up real quick and we'll go from there. I'm using crimp lock with liquid electrical tape to make it happen. Okay, probably about, I don't know, 20, 30 minutes later, and here's what you got. This cable links the negative to the positive on this battery bank. This does the same thing here, negative to positive, okay? Then I've got my positive terminal that links this battery to that battery and has about 3 foot on it to go up there along that. We'll zip tie it nice and tidy once it's down. Same thing with the negative side. Should have 3 terminals. Here's why. Negative, positive linked, negative, positive linked, negative, negative linked to the negative that goes here to the charge controller. Positive, positive linked to get you to the charge controller. So, in series and parallel is how we're connected. Now, over here at the charge controller, remember for ease of use, I put male end connectors to the end of these female connectors so I can quickly disconnect them should there ever be an issue here. Next, I'll be mounting this to the block, okay? And then I've got to run the power, positive and negative, from here to the generator motor, and then the same thing to the inverter. But in order to do that, we've got to install it in place. So I'm going to do that next. I'll put it in place and get everything drilled out for mounting the block, and we'll go from there. All right, so this is where it's going to live. It's another one of those rolls of anti-fatigue mat brought to you by Harbor Freight. But I wanted to give you a quick status update while the liquid E-tape and the paint for the control panel is curing. So here's what we got. That's the battery array. So the generator is at the end there. Look at the profile. It just looks super clean now. Mine in the trash bag. It's raining outside. I'll take that out when it stops. But I'm trying to get ready before the blackouts happen. So pretty comes later. Punk rock has an expression. Function over fashion. It's got to work before it looks pretty, but this looks pretty dang pretty. So here's what's going on. I used the square tube void to run the power that's going to go up to the controller through the channel here. I spliced the ends and I got the liquid E-tape curing here. I'm using a block. That's a pro tip for you. Use a block to separate the things, otherwise they become a gloppy mess. So while they're curing, I'll go ahead and finish laying out, pre-drilling some holes for the controller. But I got everything else dialed in, y'all. It's just a matter of literally watching paint dry. But look, you can generate power and a good workout under your stairs in the basement. I'm pretty stoked with how that's coming together. Okay, so as you saw in the last clip, this thing was running on autopilot. That's because the PWM, pulse width modulation, controller allowed backfeed into the circuit. Fortunately, I have this awesome Power Mister MPPT solar charge controller. Know that you need, in this application, an MPPT charge controller. Again, like I said earlier in the video, double check your applications and always be prepared. So anyway, I swapped it out and now everything is what it's supposed to be. Problem was, everything looks beautiful, right? It's wired in parallel, in series. Let me get all the way through there. Generator motor is perfect. Everything works. Yeah, wheels gone. Here's why. Bearings blew out. They were unsealed in the hub and they were toast. So I've got everything in a bag right here so that I can go grab some new bearings and an axle and reassemble that. But after I do that, ladies and gentlemen, we're good to go. Look at that. There we go. So after I program that, everything will be good. But as I pedaled, before the bearings blew out, we had signal. It was doing what it's supposed to do, which is charge the battery banks. 24 volt in series with a 36 amp hour rating. So the system is there. Once I reassemble this hub, the axle and bearing combo, I'll come back with part 3 and we'll wire this bad boy up to the applications for which I'll be using it. But I would say even still, super clean, ready to run. So there's part 2 of the install or build video. And like I said, it's tucked nice and neat under my staircase. So once it works, it'll be a perfect fit. Stay positive, always plan ahead, and look forward to opportunities, never setbacks. Until next time, y'all, I'm Mike, and this is the Self-Made, Self-Powered series. Episode 2 is a wrap. The system is built, it works, it runs. Now I gotta troubleshoot this bearing system, but that is a small price to pay. So I'll see you in the next video after we reassemble the hub and we build this thing out. Peace.